So 7-2 goes on page 89. It is very much a review of what we did last year because we talked about exponential growth and decay last year. An exponential function is a continuous function with a variable as the exponent, so x is the exponent, and is used to model growths or decays. So the exponential function, the parent function that we just talked about in 7-1, that's what it's describing here. It's a continuous function with a variable as the exponent, and it's used to model either growth or decay. Okay? Used to model growth or decay. And I asked you to have out a highlighter because this is what we are highlighting. So I want you to remember that growth from last year was when your graph was doing what? It was increasing. And decay was when your exponential function was decreasing. So if you looked at a picture, if you looked at a graph, you could easily tell whether it was exponential growth or exponential decay. If I look at an equation, growth, when the y value increases as the x value increases, occurs when the function looks like this. When the function looks like this, meaning that my b value right here, my b value is greater than 1. Remember last year when we talked about here's some money, is it more or less than $1? How much more, how much less? Do you remember talking about that? Okay, so I had like pictures of dollars and coins, and you had to tell me if it was more or less than 1, and how much more or how much less. And that amount more or less than $1 was the R value that we were trying to find. So that might come back in your memory as we're doing this, but growth is when you have a b value here that's more than 1, because it's 1 plus a certain amount. So the other thing that you need to highlight is decay. Decay is when y is decreasing as x is increasing. So we talked about decay is when the graph is going down. What that looks like as an equation is it looks like an exponential function with the b value that is between 0 and 1. Remember, b can't be less than 0, so it's got that bottom boundary right here. But it also can't be more than 1, because then it would be growth. So something in between 0 and 1, so like 0.25 or 5/8 or something like that, decimal or fraction between 0 and 1. If that were my b value, then I would have exponential decay. So we're going to go through some examples. That's what most of our notes are today, is just examples and picking out the pieces from the functions. So I'm going to flip this. Oh, I'm sorry. We do need to talk about what the definitions are and what the vocabulary is. So b from last year is either the growth factor or the decay factor, depending on if your function is exponential growth or decay. The a out in front is the what? It's the initial value, so it's the amount that you start with. And it's kind of easy to remember because what you start with in your function is what you start with in your equation. Y equals something here. And then finally, the r is actually embedded in the growth or decay factor, and the r is what makes it growth or decay. So either we have r as a growth rate, or this should be crossed out. We have it as a decay rate. So we're going to flip to some examples. We're going to pick out some of the pieces of these exponential functions. May I change the screen? All right. So if I want to identify the following parts of the exponential function, and I look at number 1, I want to know if it's growth or decay. So what should I look at? What part? The parentheses. This is the b value that's in here. And it's 1.25, which means it's greater than 1. It must be growth. Good. b is greater than 1. What is the initial value in this exponential function? 2. 2 is that initial value because it's out in front right here. What is the b value? 1.25. If you thought about this as money, how different would this be from $1? 25 cents, right? So the r that's actually being added here, 1 plus r, is 0.25. Because that's how much you would add to 1 in order to get 1.25. And then how would I write that r as a percent? 25%. And the way that I would get it is I would take my decimal and move it where? 2 places to the right. So that would be a 25%. And this is growth, so a 25% increase. And perhaps not everybody can see it right now, but you know how we talked about the y-intercept of an exponential function, as long as it hasn't been transformed in any way, is always going to be 0, comma what? 1, right? So we talked about that in the last set of notes. The y-intercept is always 0, comma 1 unless you've done a transformation. What kind of transformation does that do? If you times by 2, that's a scale change by 2, so it's a stretch. It's a vertical stretch, absolutely. So what would my new y-intercept value be? 0, comma 2. Yeah. So that's something that if you don't see it right now, that's okay. You don't have to see it right now. But it's just while we're talking about the y-intercept always being 0, comma 1 before transformations, that is a vertical stretch, which means that it transforms the function and the y-intercept is now 0, comma 2. So let's talk about number 2. But before we talk about it, I want you to try it. So I'm going to pause the video, try it out, compare with each other, and then we'll try and piece it together. Ready? Do you have your answers ready? Okay, so we're not going to do pick on random people. We're just going to do kind of a whole class response. Number 2, growth or decay? Decay. Why? The b is less than 1. B value is less than 1. Here's my b value, right? What is the, oh, fingers crossed. What is the initial value? 1. Good. It's always implied that there's a 1. It's not 0 because 0 times anything would wipe out the function and it's gone. So it is a 1. Good. The b value is what? 0.25. Right there. I agree. What is the r value? 0.75. So because this is decay, 1 minus the r value is 0.25. If you can see it, then you can just write it. Like $1 minus what is a quarter? Well, that would be 75 cents, so 0.75. But if you really wanted to mathematically figure it out, you could solve your little equation. You have negative r equals 0.25 minus 1, which is negative 0.75. And I don't want negative r, I want positive r, and it equals positive 0.75. So what is that altogether as a percent? 75% of a down, of a decrease? Yes. Very nice. Down arrow, yes. Which really the arrow is not necessary. It's just nice to know where your function is going when you talk about the percent. Okay? So, we're going to continue classifying each of the following exponential functions as either exponential growth or exponential decay. I want you to fill in the blanks. Try them by yourself, and then we will fill them in together. I'm going to pause the video. Okay. So number 3, I'll take some volunteers this time. We haven't done that yet. So I'll take volunteers for each piece. So on number 3, y equals 1.15 to the power of x. Raise your hand if you can tell me growth or decay. Raise your hand. Hands up. Mackenzie? Growth. Growth because why? Because b is greater than 1. Good. And as you give me your answer, if you could give it to me in a complete sentence, that would be fantastic. Okay? So initial value. Raise your hand if you can give me the initial value. Yes, sir. The initial value is what? I like it. B. Raise your hand if you can give me the B value in a complete sentence. Perhaps your complete sentence could tell us where it comes from. No one can tell me the B value? I find that hard to believe. Yes, ma'am. Oh, I thought you were raising your hand. Oh, no. Well, it's your lucky day. What's the B value? The B section. Yes, very studious. From the B section. The R value, please, with an explanation as to how you got it. Raise your hand if you can give me. If somebody doesn't raise their hand, I'm just going to pick on people. That's my favorite. Yes, ma'am. Because it increases by 15. Yeah, like 0.15. Okay. And then the percent. I need the percent from a volunteer. Yes, ma'am. 15%. Because the percent is 15%. Because you move the decimal twice to the right. Good. Okay, number 4. Let's see if you can find my mistakes. Wrong? Okay, so my decay function was right, and my B value was right. I don't want to erase it. I'm just going to mark it out and put it in a different color. What is my initial value? Why is it not 0? There's nothing there. If it were 0, the whole thing would be gone. Yeah, so what is the initial value? And if nothing is there, it is implied that A is 1. And the R value is not 0.43, it's what? 0.57. How do I get that? Subtract. Okay, so 1 minus R is 0.43. Yes, exactly. So when you think about $1 and how much you go down or up from $1, that makes it so much easier. So you guys already have that foundation from last year to help you out with this, which is great. And then the percent would have been right had my R value been 0.43, correct? But my percent really should be 57% of a decrease. Yeah. Okay.